Over the next few minutes, we'll look at 5 different security rules examples that you'll commonly use in your code. But in order to understand rules, it helps to have a decent understanding of data modeling in Firestore. If you haven't done so already, I'd highly recommend taking my data modeling course here on Fireship. A common data relationship that you'll find is a has-one relationship. In this case, we have a user's collection where each user has one profile, and that profile is a document in the database with an ID that matches the username in Firebase authentication. The document contains user profile information, which should be public to all other users in the app. However, the only user that should be able to update the document is the user that owns that profile. When it comes to reading the profile document, that should only be done by a user who is logged into the app. And we can implement that logic in our rules by saying if request auth user ID does not equal null, because if a user is not logged in, they won't have a user ID. This is easily one of the most common rules you'll write, and it basically just translates into is the user logged in. And with this rule in place, it means that only users who are logged into an account in our app will have the ability to view the profile of other users. But by itself, this rule is not sufficient to secure the user document for writes, because it would allow any logged in user to update any other user's profile. For that use case, we need something that locks down a specific user ID. The write rule begins the same with if request auth user ID, but instead of checking for its existence, we'll check to make sure that it equals the user ID in the actual path of the document. If the logged in user has the same user ID as the document, then we know that they own that document, and we can go ahead and allow the write. This type of rule works great when you have a one-to-one relationship where one user can have one document, but not all collections will work that way. Now let's take, for example, a to-dos collection where a user can have many to-dos. Each to-do item has its own unique document ID, and we maintain the relationship between the user by saving their user ID as a property on that document, allowing a user to create and own multiple documents in a collection. And keep in mind this is a root collection, it's not nested under the user's collection as a subcollection. In any case, let's go ahead and assume that in order to read a to-do document, it needs to have a status of published. We can implement that logic by checking the resource, which if you remember is the actual document itself that currently exists in the database. We'll say resource data status equals published. That means if someone attempts to read a document that doesn't have a status of published, like draft or pending, Firebase will throw an error and not send the document back down to the client. Now, like the example before, when it comes to writing a document, it should only be performed by the user who owns the document. But because the document ID doesn't equal the user ID, we need to check the actual resource data for that value. We can say if request auth user ID, the incoming user ID, equals the resource data UID, which is saved on the document itself. And also notice here how I used allow create instead of allow write, meaning this rule will only apply to the creation of a new document to the collection. And to demonstrate that further, I'll go ahead and add a second condition to our rule by saying and request time equals request resource data created at. What this condition is doing is making sure that the actual request time sent by the user has not been spoofed with a time either in the past or the future. And that's a really important thing to do when you have any type of data that is dependent on a timestamp. And it's also worth noting that it's very important in Firebase to use the server timestamp in your front-end code. In fact, it's required for this particular rule to work, and you can read more about that in the documentation. Now, the final example we'll look at is an update or a modification to an existing document. Just like create, we'll make sure that the request auth user ID equals the resource data user ID. But when it comes to updates, you'll often find that there is some data on the document that you don't want to change or that you want to stay immutable when that document was first created. That might be something like a created at timestamp or some other metadata that you wanted to save about the document, and the end user shouldn't modify it or overwrite it. For this example, let's assume that a user can only update the text and the status of a to-do item. We can enforce that rule by saying request resource data. The data, which is an object or a map, can then be converted to a list or an array by calling the keys method. The keys or fields on the document tell us exactly which part of the document the user is trying to update. We can then use the has-only method to ensure that the user is only trying to update the text and the status of the document. If the request contains any additional fields, then we know the user is attempting to update something that they're not authorized to. It's worth pointing out that the data object or map on a request or resource has a bunch of methods that you can look at in the documentation. I'll explain these as they come up in the course, but keep in mind we won't cover every single method. But no matter what you're trying to do, there's likely a solution here in the Firestore rules reference by piecing together different capabilities. For example, in the documentation, you can see here we used the keys method on the map, which gave us a list, and then on the list we used its hasOnly method to check for the existence of different items in that list. The examples we just looked at will cover a pretty large percentage of the different types of rules that you'll need to implement. In the next section, we're going to look at more advanced scenarios and ways we can improve our code for better reusability and readability.